experiment to show that that a given compound, a given compound, a given compound is an electrolyte. It's an electrolyte. The given compound is electrolyte. We have the experiment to show that a given compound is an electrolyte. So we have the experiments. We have the experiments. We have the diagram. We have the electrode, which are conductors. So these are electrodes. So we have our popular container. We have our container. So here we have a given compound X. Let me call it compound X, that we want to show whether it's an electrolyte or not. So you connect this. This one is connected like this. We have the key, call it key. We have the battery here, cells. We have the cells. This is positive, this is negative. So we have the ammeter. We have the ammeter here, like that. Then finally, we have the bulb. We have the bulb. We have the bulb. So this is the diagram. So anywhere you see this in physics or in chemistry, this represents the key. Anywhere you see something like this, the positive place is longer. This is cell. Anytime you have this is sensitive zero ammeter. This is ammeter. Then anywhere you see this one represents the bulb. This is the symbol of the bulb. This is the bulb. So this one represents the bulb. So that's the circuit diagram. That's the circuit diagram. So let's outline. The key is closed. We allow current to flow. Once the key is closed, if truly this compound is an electrolyte to conduct, and the ammeter will see the pointer of the ammeter is deflecting, showing there's current flow in the circuit, and the bulb is on, it glows. So the key is closed. So if the bulb glows, meaning the compound X, the given compound X is an electrolyte. But if the bulb fails to glow, to glow, so the given compound S, the given compound S is not an electrolyte, is a non-electrolyte, meaning it will not conduct. So that's the experiment. So whether you are asked to use the same experiment to show that a given compound is a non-electrolyte. So if the bulb glows, is on when the key is closed, then the given compound X is an electrolyte. But if it fails, it does not glow, it is a non-electrolyte. They call it experiments. Experiments to compare the strengths of different electrolytes. The strengths of different electrolytes. Electrolytes. We want to compare the strength of different electrolytes. Which of them is stronger or is the strongest? So that is what we want to compare. So we have the diagram. We have the diagram. You can use different solution. You can use 100 CNP of A2 of 0.2 mole per DNP molarity, A2SO4 of the same volume, 100 CNP of 0.2 m ACl concentration, and 0 CNP of ethanoic acid, the same concentration, that is Ca3COOH. They have the same concentration and equal volume are used. So you have our normal container. So you have the electrode. You have the electrodes. Let's use 100 CNQ of 0.2 mole per DNK of A2SO4. We are going to use the electrolyte one after the other. So we are using A2SO4 first. So we do our connection. Put the connection here. You can put the ammeter here. No problem. Put the key here. So the cell is here. Cells, battery, plus, minus. Then put the rheostat. This is known as rheostat. Anywhere you see this, you call it a rheostat, to adjust the flow of current in the circuit. That's the function of rheostat, to adjust the flow of current in the circuit. That's the function of rheostat. So this is the diagram. So what we are going to do, let's see the explanation here. Let's outline it. The key is closed to allow current to flow. Once the key is closed, the rheostat is adjusted to the maximum reading. Is adjusted to the maximum reading of the ammeter. So we are going to adjust it by lowering the resistance in the circuit so that the maximum current will flow in the circuit. So that maximum current will record the ammeter reading. So once it is adjusted, ammeter reading is recorded maximum. So it is recorded in case you use 100 CNT. So the electrolyte is used one after the other. The electrolyte is used one after the other. Meaning you first of all use ACl, A2SO4, followed by ACl, followed by Ca2CO. In each case, you record In each case, the maximum ammeter reading is recorded. The maximum ammeter reading is recorded. So you are going to record the maximum ammeter reading in each of the electrolytes. Then let's see how the table will look like. We have the electrolyte here. Electrolytes. When you use A2SO4, when you use AC here, and when you use ethylic acid Ca3COOH. Let's see the maximum current, the current that flow. Let's say this one, we'll call it I1, this one we'll call it I2, this one we'll call it I3. So let's see strengths. Strengths. How do we measure this? The maximum we determine that. So it is here you are going to have the highest, let me call it R, followed by this, let me call it medium. Let me call this to be what? Low. So the strongest is the one with the maximum current. So our remark here or observation, our observation, the current here, then the electrolyte. Our observation, it is observed that this is the strongest. This is the strongest of all. Followed by ACF, followed by A2, meaning I1 greater than I2, I2 greater than I3. So the strongest is A2SO4, followed by ACL, then followed by HCA3COOH. B now, let's say non-electrolytes. Non-electrolytes. We want to see non-electrolytes. Non-electrolytes. A non-electrolyte is a substance aqueous form, molten form, which does not allow passage of electricity or electric current and does not decompose in it. It doesn't allow passage of electric currents. We call it a non-electrolyte. So examples of non-electrolytes, examples, we talk of one. We talk of kerosene, it's a non-electrolyte. We talk of petrol, non-electrolyte. 3. We talk of glucose, non-electrolyte. We talk of cane sugar, non-electrolyte. We talk of tetrachloromethane, that is tetrachloromethane, non-electrolyte. This one is written as CCl4, non-electrolyte. You talk of benzene. Benzene is written as C6A6, non-electrolyte. Remember glucose is C6A12O6. That is glucose. Benzene, ether, ether, ether is also non-electrolyte. Ether, ether, and etc, etc, etc. So I would say notes. Note. A substance, a substance is said to be an electrolyte if one, it can dissolve in water. It should be able to dissolve in water. That's the first criteria. It must be able to dissolve in water. Then talk of solubility in water must be taken into consideration. One. Two, it must be able to, if it is okay, if it can dissolve, if it can ionize in solution. These are the two criteria. So this one, we call it ionization in solution, ionization in solution, or dissociation in solution. These are the two. For example, you have copper 2 sulfate crystal, which is solid. This one will never ionize until it is dissolved in water. Once it is dissolved in water, the copper 2 sulfate aqueous is now in aqueous form. It is this aqueous form that will now ionize to copper 2 ion plus SO4 minus. You can see dissolution followed by ionization. That's why we have it in Y. Explain or give reason or explain why copper 2 sulfate is not used as an electrolyte, whereas copper 2 sulfate crystal is not an electrolyte, but a solution is used as an electrolyte. You should be able to explain. So let me write the question on the board. Question. Copper 2 sulfate crystal, copper 2 tetrasulfate 6 crystal is not an electrolyte, but its solution is used as an electrolyte. Explain this observation. It's not an electrolyte, but the solution is used as an electrolyte. You have to explain this observation. So, solution now, it means copper 2 sulfate crystal, the sulfate 6 crystal cannot ionize because it is not in solution form, cannot ionize. As such, cannot ionize, but its solution can ionize, and its solution can ionize. Hence, the crystal is not an electrolyte. It's a non-electrolyte. It's not an electrolyte. Why? its solution, while its solution when dissolved in water, while its solution is an electrolyte. Then you give equation of reaction. Copper 2 sulfate crystal, no ionization. Hence, it is not used as an electrolyte. The copper 2 sulfate aqueous, when it has been dissolved in water, it can ionize to copper 2 ion plus SO4 2 minus. Please take note of that. That is question 1. Question 2. Question 2. Question 2. Glucose dissolves in distilled water but its solution is not an electrolyte, means a non-electrolyte. It will dissolve in water due to the presence of hydrogen bond, but its solution is not used as an electrolyte because dissolved in water, but the solution is not an electrolyte. So this is because glucose solution cannot ionize in solution. So if you add glucose C6H12O6 solid, if you add water to it, it will dissolve. C6H12O6 aqueous has passed first test. Anything that can be used as an electrolyte must be able to dissolve in water. 1, 2. The solution C6H12O6 aqueous cannot ionize. No ionization. It cannot ionize. Hence, glucose solution is not used as a non-electrolyte because the solution cannot ionize. Differences between electrolytes and conductor. We have conductor, we have non-conductor, we have or insulator, we have electrolyte, we have non-electrolytes. So what are the difference between electrolyte and conductor in chemistry? Electrolyte and conductor. So I will put electrolyte here. This is electrolyte. This is a conductor. Let's see the differences between the two. What are the differences between the two? Roman number 1. It allows passage of electricity and decomposes in it. Likewise, this one, it allows the passage of electricity, meaning electric current, but does not decompose, no decompose in it. It will not break down. That is a conductor. 2. An insulator and electrolyte, it exists in liquid form. While this one, it exists in liquid or at times solid. Okay, solid or liquid, yes. There's it in liquid or solid form. You know, metal generally, they are solid except mercury, which is in liquid form. So 3, the charge carrier. The charge carrier is ion. Why the charge carrier here? The charge carrier is electron. The charge carrier is electron in the conductor. Let me look for one more. The mode of heat transfer. The mode of heat transfer. The mode of heat transfer is, that is electrolyte, is convection. Why the mode of heat transfer here? The mode of heat transfer, the mode of heat transfer is conduction in solid. It's conduction. The mode of heat transfer is conduction. These are some of the difference between electrolyte and conductor.